Whether you're working on a street, highway, bridge, or parking lot, Cimline crack sealing equipment and materials are the best way to protect pavement structures and surfaces against water intrusion and its damaging effects. Since 1970, Cimline has focused on bringing innovative solutions to the pavement maintenance industry with a drive for performance and innovation that makes working on the job site cleaner, safer, more efficient than any of its competition. There are 3 primary sealant melter units available in our M-Series applicator machines, with numerous customizable options available on each to best suit your application needs. The M1 150-gallon melter, the M2 with a 230-gallon capacity, the M4 with a 410-gallon capacity, and the popular dual hose, dual pump configuration option. Our M-Series melters are the preferred choice by contractors and municipalities alike for being both community and operator friendly. Contractors around the world give high praise over the operator comfort of our M-Series crack sealers. All Cimline M-Series melter applicators employ a digital engine management system with shutdown protection in the case of an alternator, oil pressure, or coolant temperature fault. The diesel engine relies on a glow plug in the cylinders to start up when cold. When the key is turned to the first position, this top green light flashes for several seconds and continues to flash as the cylinder glow plugs heat up to operational temperature. When the light turns solid green, the engine can now be started by turning the key to position 2 momentarily. There is also a red auxiliary fault light that is used in case the material tank burner malfunctions. If this light illuminates, then the tank burner system needs to be checked. These lights should remain off during normal operations. If the engine shuts down unexpectedly, this is the first place to check to find out where some fault may have occurred. Cimline M-Series melter applicators are all about innovation, and ease of use has been one of the foundations of that innovation. Start the engine, turn the automated controller to the run position, wait a few minutes for the green hose ready light to illuminate, place the wand in the recirculation port, and when all 3 green indicator lights are illuminated, you should be ready to begin application. Before even considering starting up and running a Cimline melter unit, you should consult your machine owner's operator's manual for critical information on safe operations and startup procedures relating to your particular unit. The owner's manual has been written with easy-to-understand step-by-step instructions to start up and shut down your melter. The control box even has step-by-step instructions printed on the front, directing the operator on how to start up and shut down each melter unit. There is a convenient QR code printed on the front of the control panel that will lead you to the Cimline Literature and Resources webpage, where you can find copies of all of our manuals and video content quickly and easily. And finally, inside the door of the control panel is a copy of the maintenance schedule for your melter. Following the recommended hourly maintenance schedule will help keep your unit running smoothly and keep your crew on the job site safely and efficiently. The front control panel is where the automatic machine functions are controlled. When running the unit in automatic mode and before powering the unit up, first confirm that all sub-control switches are in their leftmost positions inside the control box. The front control panel switch has an off position, a run position which controls the unit automatically, a cleanout position to suck back or evacuate as much of the sealant material from the wand, hose, pump, and internal plumbing of the unit after you've finished application at the job site. And finally, a cool down position that shuts down all systems except the tank agitation. The unit should run in cool-down mode for several minutes, allowing the sealant material to agitate inside the tank as the heat transfer oil cools down and more closely matches the application temperature of the sealant material. Controlling a Cimline M series melter applicator can be done in a fully automated or manually controlled system. Our digital electronic controllers utilize both internal and external thermocouples to measure sealant material temperature and provide the most consistent control from the tank to the asphalt. Should any of these thermocouples fail to report back to the controller, the system will shut down for safety and to avoid damage to the equipment. When the unit is in manual mode, you now have individual control over all systems on the machine, including the 3 electronic temperature controllers. The ability to run the material pump in forward, reverse, or turn it off completely. Control over the agitator to run it in a counterclockwise direction, or clockwise direction, or turn it off. The top controller is the sealant material temperature controller. The second controller is the heat transfer oil temperature controller. The bottom controller is the heated hose temperature controller. The sealant material controller factory setting for material application temperature is 380 degrees Fahrenheit. The heat transfer oil controller factory setting for maximum temperature is 550 degrees Fahrenheit. The heated hose controller factory setting is 350 degrees Fahrenheit. Just below the 3 electronic control units is an amber light with a G symbol above it. When this light is illuminated, it indicates that the control unit is telling the generator on the engine to energize and provide power to the heated hose circuit. The fuse next to the generator light is a 250 volt 18 amp slow blow ceramic bus fuse that protects the AC heated hose circuit. There is also an amber light with an image of the material tank burner above it. When this light is illuminated, it indicates that the control unit is telling the material tank burner to energize and provide heat to the bottom of the material tank, heating the sealant material. The fuse block contains 10 and 20 amp blade fuses to protect the circuitry of the various systems inside the control panel. The 3 green lights illuminate brightly as each of the controlled systems on the unit become active. The top light indicates that the pump is being told to activate. This light activates when the material controller reaches 130 degrees Fahrenheit. The second light indicates that the agitator is being told to activate. This light activates when the heat transfer oil controller reaches 350 degrees Fahrenheit. The bottom light indicates that the heated hose is up to operational temperature. This light activates when the heated hose controller reaches 310 degrees Fahrenheit. When the top pump and the bottom hose controllers are showing a green ready light, then the pump motor should be turning. On the newest Cimline M series units, both material and hose controllers must show operating temperatures, and the wand triggers must be engaged before the pump motor will activate. When these 3 lights are illuminated, the sealant in the material tank should be ready, or very close to ready, for application, and the unit should be successfully circulating material through the hose and wand into the recirculation port. All Cimline M series melter applicators use a 3/4 inch inside diameter application hose. The hose is electrically heated using an AC, not DC electric circuit. Hoses are designed with a minimum reach of 20 feet. The standard application wand is made of lightweight aircraft-grade aluminum and is ergonomically designed for operator comfort on long days. The standard application tip is a 2.5 inch swivel disc, although there is a variety of application tip options available for order. When the bottom controller, the heated hose controller, shows a green light, remove the wand from its carrier. Carefully lift and place the wand securely in the front recirculation port, being mindful of possible hot sealant dripping from the wand tip. Once the wand is secure, pin the trigger on and reset the digital flow control to 9 for for maximum flow through the hose and wand. It will take several minutes for the wand and the valve near the tip of the wand to heat to an operating temperature. If applicable, open the manual valve on the wand, but first check the movement of the valve lever and open the valve only if it moves freely without forcing it. The dripless valve must be moved to its forward limit so that both wand flow control switches are activated, triggering the pump to operate and allowing full recirculation flow when the pump starts turning. It is important to place the wand in the recirculation port as soon as possible. This will allow the heat from the tank to warm up the wand tip, softening any material that may have collected in that area from the last application. Failing to do this early enough will likely appear as a clogged hose or wand and slow the startup process down until the wand is heated enough to allow unrestricted material flow. If you find the need to use a torch to heat up the wand tip on a cold unit, understand that sealant material melts at about 200 degrees Fahrenheit, and any part of the wand that you heat up only needs to be warmed, not torched to an extreme temperature, and never torch any part of the heated hose. If the wand is in the recirculation port, the wand trigger has been properly pinned, and the valve on the wand is open, then you should be able to visibly see material flowing through the wand tip, recirculating back to the material tank. You may also hear some loud popping sounds or sounds of sealant gurgling from the end of the wand and hose in the recirculation port as air is purged from the hose and wand. When your control panel is indicating 3 green lights, the pump and agitator should be visibly operating, and hot sealant material will be flowing through the system. The sealant material pump will not activate until the pump and hose temperature sensors see enough heat to allow consistent sealant flow, and this is indicated by the top and bottom controllers showing a green ready light. Current Cimline M-Series melter applicators are built with the hose and wand recirculation that is dependent on the application hose and wand being in one of the recirculation ports, and the triggers pinned to allow sealant material flow through the system and back to the top of the tank. This method of recirculation is critical to eliminate the temperature variations inside of the material tank. Normal recirculation flows back into the top of the tank and can be seen when one of the loading doors is open. Before moving the application wand into or out of the recirculation port, always check that the digital flow control setting is turned down to 0, the wand trigger is unpinned or off, and the wand valve is closed to avoid material being released unexpectedly. The Cimline M-Series melter applicator has a very safe and easy to use 50-inch loading height for proper ergonomics and operator comfort on a long day at the worksite. The insulated loading door is wide and easy to open from ground level, providing a safe and splash-free loading design. The powerful agitation system is reversible and has a full sweep across the bottom of the tank and an auger on the center shaft to maximize material turnover inside the tank. When operating a Cimline crack seal machine, you are working around hot rubberized asphalt that has been melted to a temperature near 400 degrees Fahrenheit. So it is imperative that all workers wear the proper safety gear when near these types of machines. It all starts with wearing the right clothing for the job: long sleeves and long pants with good sturdy footwear, a good pair of leather gloves with wristlets that go partway up your arms, safety glasses, a hat to protect the top of your head, and a face shield to protect your face and neck. Having this gear on hand is important during normal operations, but it's critical when loading sealant material into the machine. Workers should always load material from ground level and never climb up onto the fenders or on top of the machine when loading sealant material. If the unit you are loading has more than one door, make sure that the operators loading the material alternate opening the doors, and never have both doors open while sealant blocks are falling into the sealant material tank. It is a good practice to be continuously loading material while sealing application is going on. A steady process of loading a couple blocks every few minutes into a pool of molten sealant will ensure that the unit will not run low of material and cause the application process to halt while sealant is melted. If the material tank gets too low, then common sense says that it will take much longer to melt a large batch of cold sealant blocks. When working on the job site, crew members are usually moving quickly and are loading heavy sealant blocks from ground level. It's easy to accidentally drop a block on the ground and get dirt and gravel stuck on the block. Care should be taken to keep foreign debris from entering the tank and potentially clogging the plumbing or damaging the material pump. This debris must be removed before the block gets dropped into the material tank. Sometimes cardboard becomes stuck into the plastic or on the block itself. This too should be removed or cut away before the block goes into the tank. The plastic wrapping around the block is normal and can go into the tank. It is part of the mix design from the sealant manufacturer and does not need to be removed. Crack sealing is a preventative maintenance against water penetrating beyond the surface of concrete and asphalt that damages roads, parking lots, and trail systems. According to studies done by many of the country's departments of transportation, the application of preventative crack sealing can extend the useful life of a highway pavement up to 10 years in comparison to other temporary surface treatments. A good system of cleaning should be adopted prior to any application of sealant onto a paved surface. Knowing that sealant, much like a paint, will stick to the first thing it touches is an important fact for an operator to understand. All dust and debris must be cleaned and cleared from the application area for a successful, long-lasting sealant application. The most common cleaning method to use is compressed air or a good quality landscape blower to clean the area being sealed. For more stubborn, embedded dirt, a wire broom or brush may need to be used. An asphalt router is widely accepted as the best method of creating a clean crack with a consistent reservoir for the sealant to flow into. With all systems running properly and your Cimline unit in position, it's time to begin the application of crack sealant into the asphalt surface. Be sure you have a solid plan to be working in a safe environment and with proper traffic control in place to minimize risk to your work crew and to any other people who may come close to the active job site. In this case, the entire parking lot has been closed off to all traffic, allowing the workers to move about with minimum risk to their safety. Start by turning the flow control down to 0 before moving the wand and hose into or out of the recirculation port. Unpin the wand trigger and make sure the wand trigger is off and the wand valve is closed to avoid material being released unexpectedly. Carefully remove the wand from the recirculation port and adjust the digital flow control to the desired flow setting. It is a good practice to begin an application with the flow set between 3 and 5 until you have a feel for how much sealant you need on the asphalt surface. Walk the hose out to your starting point and set the tip onto the asphalt over the repair area. Open the wand valve and squeeze the wand trigger to begin sealant flow through the wand tip. Let the tip rest flat against the asphalt surface, and the tip will glide across the asphalt on a cushion of flowing sealant. Follow the crack, moving at a pace that allows the crack to be filled and sealed to level with the road surface. When you're at the end of the repair area, lift up on the trigger and close the valve to reduce dripping sealant outside of the repair area. Then move on to the next repair area and repeat. Avoid walking under the boom too many times and twisting up the hose. A significant kink or too many twisting rotations could cause damage to the hose. It is a good idea to make a plan with your crew on how to clearly communicate movements between repair areas.
Forward!
Clear and concise communication will keep your crew safe and more efficient. Remember to keep an eye on your sealant level in the material tank so as not to run low on material and have to wait for more sealant to heat up to the application temperature. When you are done sealing in a particular work area and you need to move more than a few paces down the road, or pause application to load more material into the tank, or take a break from the sealing application, it is important that you place the wand back into the recirculation port. Pin the wand trigger properly to allow recirculation and set the sealant flow control to its maximum flow rate of 9. This will allow you to keep hot material recirculating through the hose and wand, keeping the system up to temperature, the tank temperature consistent, and be ready for the next application activity as quickly as possible. Now that you've completed the necessary sealant applications and are ready to begin the shutdown process, place the wand back into the recirculation port, making sure to pin the wand trigger on. Failing to do this will not properly suck back the material from inside the hose and wand, so pinning the trigger is an important step. Now set the sealant flow control to its maximum flow rate of 9. This will allow the pump to evacuate material with as little restriction as possible. Turn the switch on the front of the control panel to clean out, and you should observe that the 3 temperature controllers are now off, and the tank burner and hose heater are no longer on. A quick look at the pump and you can see that it is running in reverse direction, sucking back material through the plumbing and back into the bottom of the tank. You should allow the clean out process to run for 3 to 5 minutes to properly clear the hose and plumbing system from as much sealant as possible. You can now stow the hose and wand back into their transport positions. You should set the flow control to 0 before moving the wand out of the recirculation port and unpin the wand. Take care when removing the hose and wand from the recirculation port. Nearly all of the sealant should be evacuated from the system, but you still need to be wary of unexpected hot sealant dripping from the wand tip. Place the wand in its transport tray and then secure the wand with a bungee cord. Once the wand is secured into its transport tray, press the wand valve forward into the open position when storing the unit. This allows any residual sealant to drip out of the wand tip and will make starting up the next job easier with less chance of a blockage at the wand valve. Remember to center the hose boom across the trailer and drop the boom locking pin down to secure the hose boom for transport. Make sure the trigger pin is secure and close the recirculation port and you are ready to go. The cool down process shuts down all systems except the tank agitation and is an important step that must be completed correctly. Failing to properly cool down the unit can lead to other issues from overcooked material, including tank wall buildup, clogged hose and wand or plumbing from hardened sealant chunks, and premature sealant failure after an application. The unit should run in cool down mode for several minutes, allowing the sealant material to agitate inside the tank as the heat transfer oil cools down and more closely matches the application temperature of the sealant material. Take a look at the large analog temperature gauge on the top of the material tank. This gauge shows the actual temperature of the heat transfer oil. If this gauge reads higher than the normal application temperature of the sealant material, then the system will need to agitate the material until the heat transfer oil temperature comes down significantly. Agitating the material will keep the sealant material closest to the bottom of the tank from overheating and breaking down. Taking the time to properly cool the sealant material in your tank will give the material longer life and better performance for the next job site. This is also a good time to reload some material into the tank if needed, taking advantage of the free heat left in the tank and potentially saving some startup time for the next time you plan on going out. The cool down process is not necessarily a function of time, it's a function of temperature. Don't be tempted to rush this part of the process. Use this time to clean up your work area and prepare your vehicle and trailer for travel. In many cases, the cool down time needed for your unit will exceed the time available at the job site, and you will need to keep the unit running while you drive back to your home base. This is acceptable. It is okay to run the engine and agitator while driving as long as all the items on the trailer and the tank doors are properly secure. After about 30 minutes, or when you're back at the staging yard, check the analog heat temperature oil again, and if the oil is below the material application temperature, you can shut the unit down completely.
I want to thank you for taking the time to learn more about the operation and systems on the Cimline M-Series melter applicators. We are proud to be considered as a partner to your asphalt pavement maintenance operation, and we will work hard to continue our efforts as the most innovative pavement maintenance provider in the industry.